Hi, we want to take a look at this one real quick. The things that are important here are that I see that this slows, and so it's going to, that tells me that it's going to have a negative. Sorry, I'm having a hard time here, guys. Gosh. Okay, here we go. So let's follow the rules here. 1, 2, 3. Free body diagram, right? And here it asked me to make a well-labeled diagram first. So there's my car. There it is later. No reason to think it doesn't start at the origin. It has a V initial of 30 meters per second. It's slowing, so the acceleration opposes in direction, right? There's the ground. And then later it has a V final of 10 meters per second. Okay, good enough. Free body diagram, no reason to think that it's not balanced in the Y. Force gravity on car by earth. Force normal on car by surface. Those are balanced. I'll use congruency marks to show that. In this case, I could say certainly something's slowing it. I'm going to say there's a force friction. It could be a braking force. I could also have an engine force over here. Not an engine force, but a traction force if I wanted to. But I could just consider that maybe it runs out of gas. How about that? So I'm going to say runs just for a different scenario. Since they didn't say out of gas, I don't know why it's slowing, but I'm just going to say that friction is causing it to slow, and I'm not going to consider anything over here, and that's okay. So if I look at X equality, right, that's my next thing. So it's FBD and then equality and graph annotations and then math. Okay, so X equality is F net equals whatever's slowing it, frictional force or braking force or whatever. And then in the Y equality, we said that F normal equals FG. We don't see any net force there. So F net equals 0. Okay, so if I go to the graph, what I know is that I think I'm just going to look at it this way and say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So it starts at 30 and goes to 10 in 5 seconds. So 30 to 10 in 5. So there we are, right? And so I could certainly find, I can see the acceleration is negative. I could solve for the slope here. Right? I could just, use the graphing and solve for the slope. Or I could say, because they want us to find the acceleration, so I could find the slope. Or I could say V equals AT plus V naught. That would be an easy way. Right? So it would be what? 10 minus 30 over T, which is what, 5 seconds? Equals A, which equals -4. And that's good for us because it's slowing, so -4 equals the acceleration. Great, so it wants to know the distance traveled, and the distance traveled, we could get it one of two ways. We could certainly find the area under here, okay? And that would be just fine. So let's see if we wanted to do that. We could say, I'll just do it this way. We could say, maybe 1/2 if I wanted to find the area under here, 1/2, so I could say that the area under, which is how far it's gone, right? So the area equals 1/2 base times height, yeah, plus length times width, okay? So let's see, what do I think? I think, hold on just 1 second, get the different colored pen. Okay, guys, I was sort of finding the distance it travels for the whole 5 seconds, which ends up looking like about 100. But when I look back and actually read the directions, which is, phenomenal to do, then I see that what they really want is they want us to find the distance it travels just in from during the 3rd second. Okay, so that's great, during the 3rd second. And so if we come over here, what's important to know, so I think I'm going to just erase this. I think we can still do the area, but it just needs to be the area in the 3rd second, which is fine. So the 3rd second, so there's the 1st second. There's the 2nd second. Here's the 3rd second right here. Okay? The 3rd second. All right. So let's just find the area for the 3rd second. Okay, so if I look at this little area here, then what I see is lengths. I see a rectangle and a triangle. It's kind of tight up in there. But the rectangle is length, and I made this the length. Probably it should have been the width, but who cares, right? 1 second times, and I called this, I don't know, about 15. So 1 times 15, length times width. And then the triangle, I said, was 1 second for the base, right? There it is, that 3rd second, times 7.5 meters per second for the height. So 1/2 of that. So we end up with x equals 18.75. Now let me tell you this. If you wanted to use x equals 1/2 at squared, that would be perfectly fine. Just like this equation. But let me tell you where people get into trouble. First of all, there's no x naught, right? We're starting from the starting line. But the v naught for this 3rd second is something different, right? So I would have to read that off right there and get the right thing there. The way people get in trouble is by just saying v naught is 30, okay? So watch out for that. Okay, and in the end, the V naught ends up, you can see the similarity, right? 1/2 base times height, 1/2 AT. So the similarity layout it's not identical, but it's very clear, clearly related. And so you just want to watch out for that. Kind of trip you up. Okay, let's see. Coefficient of friction between the tire and the roads. If the only force decelerating the car is the force of friction. So if I read through the whole problem, then that would explain why I chose to do it like that. So coefficient of friction, I would just say that we know that force friction is the only net force, right? So we can say F net equals force friction. It equals mu force normal. That's an N. It equals mu, which is what we're looking for, times mg. Yeah. Okay. And so what we know, here's what's interesting. F net also equals ma, right? So I'm just going to say, hey, F net equals ma also. So F net equals both of these things, mu force normal, since it's force friction, right, and ma. So here's what's interesting. We have mass here and here. So if I look, I notice that I wasn't given the mass of the car, and that can kind of be upsetting. When you see that you're not given mass and you start to feel like you're going to have to fret because you don't have it, look for an opportunity for it to cancel out. So now acceleration just equals mu g, or mu equals a over g. All right, did I find A? Have I solved for A? Yeah, it looks like I did. -4. So, right, so -4 meters per second squared over 10 meters per second squared. Yeah, and that's nice because it's 0.4 equals mu, and it's a number between 0 and 1. So that's all really good for us. Great.